Okay, let's start. So my name is Vojta. I work as a director of platform engineering in Sequence XYZ. In Sequence, we are building the leading Web3 development platform, which is used by many online games, including games from Ubisoft. And also, I'm a founder of Golang.cz, which is a software agency, and we are helping companies adopt Go, but also we are building web applications, software solutions. Go is our obvious choice on the backend side. We also use React and Svelte on frontend side, and Kubernetes, Pulumi on the infrastructure side. So today, let me see if this works actually. Can you guys still hear me? No? They cannot. Okay, so I will need to be using the microphone, I guess. So today I want to talk about webrpc. Building REST APIs in Go or in any language can be time-consuming and cumbersome, especially when you build the API for many customers and over time. How many of you have built any APIs in Golang? That's a lot. Perfect. How many of you built JSON-based REST API? Many people, great. How many of you are using gRPC? That's a lot too, that's great. So when you're building REST API, of course, you need to create the server routes. This is an example code, a sample code, how things might look. Starting Go 1.22 with the new syntax. So you need to start by defining the routes and your router. As you can see, this is an example of a simple CRUD endpoint for users. Create, delete, update users. Then you need to implement the server handlers for these routes. It may look something like this. I think it will be familiar to everyone sitting in this room. So first we have an example of a data model. So in this case, it's a user object. We are creating an update user handler, which first decodes the request body into this runtime object. Then we finally have the incoming payload in the runtime object, so we can do some stuff with it. We can validate it, sanitize it, save it to the database, load it from the database, whatever. But at the end of the handler, we need to send some response back to the user, back to the client. So of course we need to set the HTTP status code, and we need to encode the object back to JSON and send it over the wire using the response body. So for this, we usually use, when building JSON-based REST APIs, we use JSON unmarshal or JSON marshal or JSON decoder and encoder. So at this point, we have a working server handler. So we could be using curl or something like that to invoke that server. But of course, if we want to maintain a set of APIs, we need to test it or we need to communicate from one service to another. And so it's probably a good idea to write some clients. So usually when you're writing a web application, you will need to write a client in Go and in JavaScript or in TypeScript. But if you have customers that use other languages, then you will need to implement it many times more. So this is an example of a client method. So in this case, this is invoking the handler which we created before. So first we need to create the response and marshal some payload into the request body. Then we send it over to the server. We get some response back. We get the status, and then we can decode the body. This is an example of the same thing in TypeScript. So again, you can see that we have some runtime object. We need to encode it, send it over the wire, and receive it back. All of this code feels like duplication. It's a lot of boilerplate. But also we should need some API documentation that is up to date. So we need to maintain it over time. And when we're building the REST APIs for customers that should last for a long time, then we need to repeat the process. So any single time we need to add a new route, or we need to break some contract, we need to do all these steps over and over again. Is there a better way? So today I want to introduce you to webrpc, which is a framework which helps you code generate REST APIs. It is heavily inspired by gRPC from Google or Twerp from Twitch TV. webrpc speaks JSON. Hello? webrpc speaks JSON over the wire, and it's 100% compatible for web, which means you don't rely on HTTP2. It works from web browsers. It works with all the load balancers and all networking and infrastructure out there, because it's just a REST API. And the services, or aka the protobuf, are defined in JSON or RESTful file. webrpc is code generation tool, and as of today, we support Golang on both client and server side. We also support JavaScript and TypeScript on both sides. And we also have support for Kotlin, Dark, and OpenAPI documentation. What's really cool about webrpc is that all of these generators are just simple Go templates. So they are all available on GitHub. They are open source. You can fork them, you can make any changes to them, and you can co-generate your clients with ease. This is an example of a RESTful file, which is a schema definition file for webrpc. We are defining a service called example API with bunch of endpoints. The first endpoint is just a ping, and then we have 5 more methods for users CRUD. This is the data model, which is actually being transferred over the wire using JSON. And at the end of the file, you can notice some custom errors, which we have defined as part of the API. So with webrpc, it's much easier to maintain the APIs over time, because there is less code that you need to maintain. All you need to do is code generate your client in many languages, code generate your server code, and then all you need to do is implement the server methods and maintain the RESTful itself. WebRPC also supports streaming, which is a server-to-client one-way streaming using ND-JSON, which is new line delimited JSON. We also support enums that are then transformed into IODAs with proper marshallers on the Go side. But they also support enums in, we also support enums in TypeScript and JavaScript. The Riddle can handle multiple services at the same time. We also support annotations, so you can mark and annotate individual endpoints with some annotation, and then you can use this to either you can use this in a middleware, for example. So I'm able to create an endpoint which has authentication, for example. And with annotations, I can mark it as required. And it's time for demo. Now you can go on a train with me. Great. Okay, so I have prepared this example. Can you guys see the code even in the back? Is it okay? No? Let me make it bigger. How about now? Perfect. So this is example what I was showing you before, right? It's a riddle file with the service definition. We are defining a REST example API with a single RPC method. And this method will then auto-generate REST API endpoints. How does this look from the Go perspective? So in order to create a server, I just instantiate a server which has the handler, which is auto-generated, and I let it listen and serve on specific port. If I dive into the server implementation, now this could be any server that you can imagine, right? Including having configs, PGX connection, custom loggers, you name it. This is the handler itself. So first I instantiate the WebRPC handler, and this is where the code generation kicks in. So I pass my implementation, which is this server, into the code generated code. And it looks like this. So this is a code generated server. And as you can see, it does exactly what you would expect. It handles all the JSON marshalling and unmarshalling, all the encoding and decoding for free. And then it calls your server implementation, which is the method itself. Then I define a chi router. What's cool about WebRPC is that it's 100% compatible with standard library, with HTTP, but also with Chi or with any other router out there. And so you can actually use HTTP middleware. You just mount these new endpoints side by side to your existing endpoints. So if you have an existing REST API, you can start using WebRPC side by side to it very easily. And also you can reuse the very same middlewares that you already use right now. So for example, this is an example from Chi middlewares. I can set up a trace ID middleware. Maybe I want to have a timeout on all of the endpoints. Maybe I want to use Chorus middleware, something for rate limiting. There's a great package from GoChi for very efficient HTTP rate limiting. You can set up Prometheus telemetry or OTel, open telemetry, request logger, and anything like that. And as you can see, I just mount the WebRPC handler. And that's it. So now where is the logic? The logic is on the server methods. Here we go. This is my implementation of the endpoint. And as you can see, there is nothing, no boilerplate around HTTP. No HTTP request, no HTTP response writer. This is being called by the auto-generated code. So all I need to do is to work with the payload, with the incoming payload, and then I return an object which will then be encoded automatically. And that's what I have so far. So how about we make this more interactive and you guys tell me what other endpoint should I implement in the API? Because I just want to show you how this feels. Any ideas? Safe user, thank you. I thought that I would be waiting forever. So what do I need for saving user? Do I just autocomplete AI? I guess I could. So now I changed the service definition, and all I need to do is to go into my terminal, and let me make the font a little bigger. And can you see it? Good. And if I run make proto, maybe I should show you the makefile first, just so you understand. So in the makefile, I have this proto target, which actually invokes the webrpc gen, which is the generation tooling. It will, as an input, that's the example riddle file that I was showing you before, and this is the output. So I'm actually specifying the target here. I am auto-generating Golang client. I'm also auto-generating Golang server, and I'm auto-generating OpenAPI and TypeScript client. So now if I run this, that's it, super fast tooling, which is actually part of our Go mod file. This is, let me actually show you. If I take a look at Go mod, the webrpc tooling is just a tool inside of Go mod. Now, it was super fast, but what it actually did? It auto-generated some new code for me. And as you can see, it auto-generated a new handler for me. So this is the new safe user method which we defined. And it does decoding and also encoding for me. And it also, actually this is an example of a client. So this is a client encoding and then decoding. And there will be another example with the server code. Yeah, this is it. So this is the server handler, where we first decode the request body and then we encode it back. And in between, this auto-generated code calls my method. So now if I run this, I'm running my server, and the server is complaining, hey, we are missing a new method, safe user. You need to implement it. So let's implement it. So this is how it should look like. This is the interface that it generated for me. By the way, if you see this interface here, you can use it with any tools that can generate mocks for you. So for example, the mock gen from Uber works very well with this. So now let us implement a new method on our server. And for now, I will just return nil and some random error. Not implemented, that's a good one. Now, as you can see, the server is already working. So it's listening on port 553, and I can spin up my tests. Now let me show you what are those tests. The test is actually using the auto-generated client, and it's talking to the server that I span up in the top window. And on the window in the bottom, I'm just spinning up these tests. So as you can see, I instantiate the new client. I can provide my custom HTTP client implementation or any other custom transport that I can pass into it. Then I have some with timeout context, and I just call the method directly. But it feels like it's calling the method directly, but it's actually over the wire. This is JSON communication between, right? So this can be used for not only for tests, but actually for service-to-service communication. There's a question?
Yeah. So in the title on the top, it specifically said that it's about creating REST APIs. Where is the rest in it?
Where's the rest in it?
Yeah, what are the URLs and like, you know, like.
So this is not
all about the resource identifiers and.
So this is REST API. This is not RESTful API. Okay?
REST API is actually, that's the original clearly specified. Like that's stronger than the rest.
Okay. So we're generating JSON APIs. Better?
Okay, so it's not really okay.
So now we can use the new method which we defined just a couple minutes ago. Okay? Let me use some help from AI here. So I can do API save user, and if there is an error, I will error out. I'm running the new test which we just written, and we are getting not implemented error back from the server. So now let's say that we actually, you know what, let's just return the very same object that we receive. So in this case, it would be empty payload. Otherwise, I will just pretend that I save it to the database, and I will return it back to the user. Okay, let me rerun my test. Empty payload.
You have the exclamation mark over there in a if statement.
Yep, good one. Thank you. So now my test passed. And so this is how it feels with webrpc to create new endpoints for your REST API or JSON API. You can maintain it very easily, and you will never make a mistake because all of the code is generated, all of the handlers, all of the payload, all of the objects. And what's cool is that you are also generating the client for many other languages, including TypeScript. So a front-end developer will never make a mistake because all of the attributes that they send to your API are strongly typed, which is cool. But also, as I mentioned before, we are also generating Swagger API, OpenAPI. So if I run it right now, make Swagger, and I go to that page, you can see the new save user method generated in my OpenAPI. And this is what I can have on my, inside of my server. This is what I can share with my customers. Always up-to-date documentation. Last thing that I want to show you is that we also support some annotations, and one of the annotations is deprecated. What this annotation does is, so let me run make proto and make Swagger again. This annotation just marks those endpoints as deprecated, as you might have guessed. So in Swagger, we already see that the endpoint is crossed over as deprecated. And if I switch back to the tests, I should be able to see the method crossed here as well. But it looks like my ID is slower or something like that. Yeah. Actually, I see the problem. Use save user 2 instead. Make proto, make Swagger, and actually here in the code, in my test, now I see that the method is deprecated. And I can use this for service-to-service communication. I can use this to actually test my API, but also I can use this as an SDK. I can share these files with my customers. And that's exactly what we are doing in Sequence XYZ with great success. With JSON, if you compare it to gRPC, because what I was showing you is quite similar to gRPC, right? But what is great about gRPC is its speed, right? But also like binary protocol, but also binary streaming and many more features. But one of the features that really stands out against JSON is its speed, especially if you have a large payload or if you have a big JSON with nested objects. But that's compared to standard library. These days, we have some alternatives. So you can see this chart. So for example, JSONitter, which is a package, Go package out there, and it acts as a drop-in replacement for standard library encoding JSON. And it's like 4 times faster to encode and also decode JSON. But Sonic from ByteDance, which is a company behind TikTok, is even faster. And we're talking about like 8 to 16 times faster. And at this speed, with the JIT compiler that they come up with, at this speed, we are actually on comparable speed with gRPC. But we have all the benefits of being native JSON communication that works from browser without any sidecars. And this concludes my talk. Thank you very much for your attention. If you have any questions, shoot it at me. Thank you.
Okay, now that I know what it is, did you actually write the entire RPC logic from the ground up, or are you using something like JSON RPC on the background?
So the question is if we wrote the WebRPC from ground up or not. Yes, we have. So even though the project is heavily inspired by gRPC and also by Twerp, those are projects already available on GitHub. WebRPC was written by Peter Kieltika, and we are working together on this project right now. And I mentioned it already. What's really cool about webrpc is that it's all open source on GitHub, and you can write your own generators very easily because they are just Go templates.
Can you specify in that reader file the errors which the specific method can return?
Can we specify which errors can be returned by what endpoints? Great question. No, we cannot. So the errors are actually part of the API contract and they are global. So you have to write some extra annotations. That's what you could do to showcase like what I can return from this endpoint to the client. Good one. Any more questions?
How would you write a custom client in another language?
How would you write a custom client in another language? So let's take a look at how this looks. WebRPC on GitHub. So this is the project on GitHub. And this is just the schema definition and the JSON format that we use. However, if you go to webrpc-golang, gen as a generator, gen-golang. This is the Go template, which actually is responsible for generating the client code and also the server code. So if you want to take a look at the server code, it's a regular Go template, which defines an interface, which goes through all the methods that we defined in the riddle file. And then, you know, it implements the serve HTTP method, so it can act as a handler. And then it has a range statement over here. Across all services and across all of its methods, we define a server method which does the decoding and encoding and which calls your implementation that you're supposed to pass into this object. And yeah, currently we have support for, let me go back to this page. If you go to the main GitHub page, we have a table with these generators. So currently we support Golang, TypeScript, Kotlin, Dart, OpenAPI. There is also a work in progress generated for code generator for Python. But as you can see, it's just a template. So you can fork it, you can customize it, or you could even write your own for Java or for any other language. Thank you for the question. Any more questions before we wrap up? Go ahead.
So, is there a way how you can define the method? I mean, like get closer to the REST API. You mentioned that I want to have an ID in a path and define the method to not to have it to be on always post, but something else. Is it possible out of the box?
The question is if we can customize the schema so it looks closer to RESTful APIs. So you can have an ID inside of a path, and so you don't have to use post method all the time, right?
Yeah.
No, unfortunately not, but that's actually by design. We have designed WebRPC in a way so you don't ever need to think about RESTful structure, and so you don't have to think about methods either. So if we return something and it has error, you can define the status code. Also, you can define a type of the error. But if it's successful, it's just always 200. So yes, the framework is quite opinionated, and that's by design. Any more questions? Last question.
So you can define a type in the reader file, specify that field is required, optional, or some other bounding constraints?
So the question is, when we define something in Riddle, can we define if it's an optional field or required field? Yes, we can. So for example, this sort of, is a blend between Go and TypeScript syntax. This little question mark here means that it's an optional field, right? And in this struct, I could be using more structs. I could be also embedding structs. I could be also using maps or arrays. And I can also import Riddle file from another Riddle file, so you can create your data models, and it plays really well. All right, that was the last question. Thank you so much.